Yo, what's up, guys, and welcome to another informative and amazing video of my channel Smarter Everyday. And in this video, we're going to be continuing with our chapter Acid, Bases, and Salts of the subject Chemistry, and this is going to be part 2 of the video of this chapter. And this chapter is going to be very easy. So, why to wait? Let's begin. But before starting, don't forget to like, share, subscribe, and comment to our channel. So, now let's begin. So the points to be covered in this video are: first, we will get introduced to bases, then we will see the relationship between bases and alkalis or alkalis, then we will see the classification of bases, then we will see properties of bases, in which we will see both physical and chemical properties, then we will see the common uses of bases. So now let's move to our first topic, that is introduction to bases. So bases are chemically opposite to acids in nature. So in the last video we had seen how acids react, and bases are exactly opposite to acids in nature. Bases have a bitter taste and they have a soapy feel. Bases neutralize acids, and when bases dissolve in water, they form OH minus ions that are hydroxide ions. And these hydroxide ions are available to take part in chemical reaction. This means that these ions are independent and they can take part in chemical reactions independently. So let's see some examples. So the first one is baking soda, that is made up of sodium bicarbonate, that is a base. Soaps, that is made up of sodium hydroxide. Detergent that we use of fertilizer is made up of ammonia. Now here we can see that here it was given that bases have a soapy feel, and here we can see an example also, that is soap. They are of course soapy and slippery also. So hence different daily use items contain different bases. Now, what is a base scientifically? What is the definition of a base? So, a substance which gives hydroxide ions, that are OH minus ions, when dissolved in water is called a base. And below in the picture we can see some dissociation reaction, and in the last video we had seen what is a dissociation reaction. So let's see. So the first one is NaOH, and when it dissolves in water, it splits up and forms Na plus and OH minus ions. Second one is Ca in brackets OH twice, and when it is dissolved in water, it splits up into Ca2 plus and 2OH minus. Now let's move to our next topic, that is what is the relationship between bases and alkalis. And here alkalis is an important term. So some bases are soluble in water whereas some are not. So now in all these bases, some are 100% soluble in water. They completely soluble in water, but some are not. They partially soluble. Now the bases that are soluble in water are called alkalis, and whereas there are some other bases also that are not soluble in water, and this below diagram shows it completely. Now we can see that these are some bases, and in bases these are some alkalis. So what are the alkalis? NaOH, that is sodium hydroxide, KOH, that is potassium hydroxide, NH4OH, and Ca in brackets OH twice. These are all 100% soluble in water, but these on the outside of the alkali circle are not soluble. They are partially soluble. Some are CuOH twice, MgOH twice, and so on. Therefore, we can say that all alkalis are bases, but not all bases are alkalis. This statement is a golden statement, and it is very important. We can even say that all the alkalis are strong bases because it 100% splits up into water. So that's why it is a strong base. Now let's move to our next topic, that is classification of bases. So bases can be classified into the following categories, that is only one actually. So that is on the basis of strength. So strong bases, that are bases that dissociates, that splits up completely to form more OH minus ions when dissolved in water. Example, sodium hydroxide and potassium hydroxide, and as I told you, these both are alkalis and all alkalis are strong bases. This is also very important statement. Well, now weak bases. Bases that partially dissociates, that is splits up, dissociates completely but forms less OH minus ions when dissolved in water. Example, copper hydroxide and magnesium hydroxide. And these two examples are not alkalis. Now, there's another term coming up, that is acidity of a base. Now, what is acidity of a base? It is the number of replaceable hydroxide ions present in the molecule of any given base. So now, on this term, bases are classified as three categories: monoacidic, diacidic and triacidic. Now let's move to our next topic, that is properties of bases. We'll see both physical and chemical properties. Now in physical properties, the taste, we have seen already that bases have a bitter taste. Nature, they have a soapy touch. And what do they act? How do they act with indicators? So indicator is any substance that changes its color when it reacts with acid or a base, and it helps us to know is it a base or an acid. Now bases turn actually red litmus paper blue, and they exhibit yellow color with methyl orange, and phenolphthalein is actually colorless, but now in bases it has a pink color. And solubility in water, we have already seen that some bases, actually most bases are not soluble in water, but some bases that are soluble in water are called alkalis. Now what are the chemical properties of bases? So how do bases react with acids? So bases react with acids to form salt and water. This process is even called as neutralization reaction. This is the reaction of that acid plus base yields H2O, that is water and salt. Even I can give an example of this. When we don't eat food at intervals, like exact interval, we sometimes eat food late or early, we see that our stomach starts paining like acid. So in our stomach, when more acid is released, it becomes acidic and our stomach starts paining. So for this we take something called eno or digen, something etc. So these things that like eno and digen, they have a base. We will see that further. So they have a base which, so there's acid in the stomach and we put base, so it gets neutralized and then we feel relaxed. Now one more term is coming up. What is basic salts? So basic salts are the salts which contain one or more replaceable hydroxide ions. These are only formed when a diacidic or a triacidic base is partially neutralized. So an example of this can be when there is a strong base. We can take strong acid. So the acid is very strong. But so to neutralize that strong acid, we need a strong base also. Both should be equal. Then only it gets neutralized. But now the base is not that strong. It's medium. It's not that strong. So when they neutralize each other, but there is still some acid left. So that's when basic salts are formed and not normal salt. And this is very important, basic salts. Now let's move to the next topic, that is we'll see some common uses of bases. Now what are the uses of sodium hydroxide and potassium hydroxide? They are used in the manufacture of soaps and paper. They are used in refining of petroleum. They are used in cleansing agents like detergent, etc. Slake lime is used as whitewash. It is used in laboratory for testing carbon dioxide gas. It is used for neutralizing acidic soils. This is a neutralization reaction again, the third point. It is even used in manufacture of bleaching powder, cement and mortar. Now, magnesium and aluminum hydroxide. I was talking about these two bases. These are commonly used as antacids, that is a medicine, to neutralize the acidity caused by excess of acid in our stomach. Some examples are ENO, Digen, etc. Ammonium hydroxide is used in the manufacture of fertilizers. It is used in the manufacture of dyes, plastics, artificial fibers like rayon. So guys, that's all for this video. I hope you liked it and it helped you also. So thanks for watching everyone, and please don't forget to like, share, subscribe and comment our channel. So we'll meet in the next video. Till then, goodbye.